Hey, it's me again. I messed up, so now there's two videos, and man, that annoys me more than it annoys you, I promise. That's 2 YouTube uploads. Okay. That's what I meant to do. If you would, please copy down the reaction, just the yellow highlight part. For those of y'all at home, they're copying the part that looks like it would be highlighted. Of course, always pause the video when necessary. What I see in the reaction is 2 aluminums reacting with 1 nitrogen to produce 2 aluminum nitrides. So we know it's balanced because there's coefficients there. I would never half balance a reaction for you, but you can count if you care. Then it gives us a scenario. All right, we've got a certain number of or it's asking how many liters of nitrogen at a certain setting are required to react with 18.5 grams of aluminum. So let's think back about our trick. We know that if we're dealing with a reaction in gas laws, that we're going to have to use Pivnert alongside Stoic. But look at what it's asking for. All right, asking for liters, which is units of volume. Do you expect Stoic or ideal first? Stoic first. And here's what I really see. I see that I've got all of these gaseous setting descriptors of the item it's asking for, but the given data is really just the 18.5 grams of aluminum. So what I'm going to do is take the 18.5 grams of aluminum and I can turn it into moles. You see your moles from Pivnert of the item it's asking about. And then I can use all of the other stuff it's already telling me about the item it's asking about to fill out the rest of the ideal gas law. That was a big sign. Okay, so I don't want the grams of aluminum. I want moles of the item it's asking about to plug into Pivnert. Now, looky. Are we happy to start with grams? All right, here's our Stoic flashback. You're like, I don't kind of know. No, we don't like starting with grams. All right, we can only start moving to other things if we have moles. So I don't want grams of the aluminum. I want moles of the aluminum. But once you have moles of an item in the reaction, that can always go to moles of any other item in the reaction. And this question is having us analyze nitrogen. So there's the conversion set up across the top. Now I'm going to drag my diagonals, but not the number. Drag your diagonals. Now, in case you've forgotten and I know you don't have these notes out, I give you some conversion reminders for Stoic. Remember, if moles is being compared to grams, the conversion factors is 1 to periodic table. But if moles is ever over moles, the values come from the balanced equation. So looking here, moles is over grams. Moles to grams is 1 to the periodic table of aluminum, which you've got it out. Sorry, I don't know if I told you to get out. Have your periodic table out at home. Aluminum is 26.98. There's nothing to add up there since it's just aluminum. When moles is over moles, the values come from the coefficients. So check up there and you will see that nitrogen has no coefficient, so it's 1. And aluminum drops a deuce. Multiply across the top, get a number. Multiply across the bottom, get a number. Divide the top, divide the bottom, watch your sig figs. Do you get 0.343? Remember, the units of your answer here always match the units in the top right square, in case you forgot, which of course was the point. We have all these other values that are describing the gaseous setup of nitrogen. We just didn't have the moles. And now you'll see that we've got everything we need for Pivner. So let's set it up. Let's see if we have a pressure. I know that torr is units of pressure. So 892 will be the P. Volume is what we're looking for. Moles is what we just calculated. Ooh, we need an R value. Flip back. You've got R values in your previous notes. Remember, you don't have to memorize them. Just make sure you know how to find them. The R value is chosen based off of the units of pressure. Now, if you're looking at that and you're like, you didn't give us torr. I did. If you go back to a week ago when we started converting pressure units, we did cover torr there. And it was the exact same conversion factor as millimeters of mercury. All right, so MMHG and torr always have the same numbers. Therefore, the R value for MMHG is also the R value for torr at 62.4 that wasn't supposed to run. And then the temperature is 95 degrees Celsius. Does that give you a warm, happy feeling? It should give you a warm feeling because that's actually really hot, but it shouldn't give you a happy feeling because degrees Celsius, no good. Must be Kelvin. Add 273 and you'll get 368. No, so torr is 760 for its conversion factors into the other units. The R value is 62.8. 62.4, because that's what MMHG is. So the R values and the conversion factors are two different numbers. So just flip back, look at MMHG from yesterday for the R value, and you'll see why I'm using what I'm using. I know I always break this down and I treat y'all like sixth graders by showing you all of the steps. You do know you should be doing all of this math as a singular function on your calculator, right? Like when you see this, your brain should go, okay, well, everything on the right is going to be divided by everything on the left because the variable's on the left. So I hope in the background that most of y'all are going this times this times this divided by this without doing a bunch of different functions. Anyway, I get a volume of 8.83 liters. Remember, only liters can go in or come out of the ideal gas law. Anybody have any intro issues? All right, we've got Aspen in play. We're not going to hit the wrong button on the computer. Here's our new problem for those of y'all at home to pause. Do you see the phrase STP there? Have y'all run into STP on your assignments yet? at all? Okay, so 2 lectures ago, I went all the way to the bell and I said there was an extra slide, but I knew I wouldn't get to it, so I gave you that cheat sheet because of it. So I'd like to remind you that at the bottom of said cheat sheet was a bunch of vocab that I said you absolutely need to know. And those of y'all that have been working on your Schoologies, you've been probed about some of this stuff, compression, expansion, stuff like that. So it's there and you're responsible for it, but I want you to find STP on that part of your cheat sheet if you haven't already. STP stands for standard temperature and pressure. It's a standard number for T and a standard number for P that applies to a lot of situations. You don't have to memorize those numbers. It's on the formula chart. So again, it's just something to go look for. But if you look at this problem, it looks like we're short numbers. It only gives us one number, but not really, because it says that we are existing at STP, which means that there's more automatic numbers. 1 atmosphere is 0 degrees Celsius. So be on the lookout for that. Let's draw some cards. Cluster 1, let's start with y'all, 1-4. Hey, 1-4. Looking at the wording of this question, do you expect that we'll go ideal then stoic or stoic and then ideal? He says ideal then stoic. Agree or disagree? My quiet eighth period. I agree. Yeah. All right. You see how it's asking for grams this time? All right. It's different than last time. And if you look at your little trick at the beginning I gave you, that almost always means that you're going to start with Pivnert in this case. What I see, though, is it's asking for grams of ammonia, and then it's giving me a bunch of data on hydrogen, a bunch of gaseous data on hydrogen. So what I'm going to do is take all that gaseous data on hydrogen, turn it into moles, and then I can do stoichiometry to convert it to the other compound it's asking about, the ammonia, NH3. So let's see if we can plug in our gas data into the ideal first, starting with P. Go over to cluster 1 again, C4. Are you having fun yet? Hey, 1-4, what value will I use for pressure here? You're right, but what number? 1. Yeah, he said 1. Because it's STP. Did I just annoy you? Oh. Because it's STP and P is 1 atmosphere in that phrase. All right. Volume is given directly to us, 24.8. We're happy with those units because it's liters. Only liters can go in or go out. We're going to find moles, and that's what we can later plug into a stoic grid to convert it to grams of another thing. We need an R value. Let's go over to cluster 4. C3. Hey, 4-3. 4-3. Do you have an R value for me? All right, so remember, my R value is going to be based off the pressure units. This 1 is in units of atmospheres based on STP. What is the R value for atmospheres? Perfect. All right, and what temperature will I use? 273, right? Because STP says 0 degrees Celsius. Celsius is no good, but 0 plus 273 is pretty easy math. I'll draw a card for this value in just a moment. Go over to cluster 2. Talk to seat 6. Hey, 2-6, do you have a mole count for me? Perfect, 1.11. You know, if you just get the confidence look in your eye once, I think every time I've ever called on you, you've gotten the answer right. But you still look like I ruined your day. Okay, yeah, I get 1.11 moles. We good? Now, those moles are describing the hydrogen because all of those values that we just looked at were describing the hydrogen. Sorry, taking the dinner order from my daughters. There you go. And we don't want anything to do with hydrogen. We want to describe ammonia. So what I'm going to do then is take the 1.11 moles of hydrogen, and I can convert that directly into grams of ammonia. So look here, this one's a little different. I'm starting with moles, which makes me happy, because if I have moles, I can then automatically go to another substance. So I'm going to convert directly to moles of the ammonia. Once I have moles of the ammonia, I can go to other units of ammonia, and it wants grams. Again, if this part is making you not like this lecture, it's because you're stoically challenged, and we need to work on it. If you didn't learn it before, you are capable of learning it. I promise you are. Let's drag some diagonals. And let's get some help on these squares. Let's go over to cluster 5, seat 6, Aspen. Looking at the setup on what's over what number should go in that square? 2 is correct. You can pass the bird. The way that she got 2 is moles is over moles, so she knew the numbers needed to come from the coefficient, so she found ammonia up there, and it was 2. The coefficient for hydrogen is 3. Here, grams is with moles, so it's the blue information you see there, which states that 1 mole is equal to PT grams. We need the molar mass of ammonia, which is nitrogen plus hydrogen plus hydrogen plus hydrogen, 17.03, because I'm nice. Answer to the question is awaiting you. Questions before you prove you can do this without me? So the question was, how did I know that 1.11 moles was describing the H2? If you look here, every little part of these two expressions is describing the hydrogen. It's this volume of it, and this is existing at that, which is why I know that all of these values can happily go into PivNert because they are all describing hydrogen. Not a single one of these values is necessarily describing the ammonia, just based on the way it's written. That's why I know if I can put all of these together to get something that is stoichiometrically helpful for a different substance, then I want to do that, right? And PivNert is what can get me to moles in terms of my gas laws, right? None of your other gas laws have moles there, which is why the ideal gas law is what we're using here. So I'm putting all of this information for hydrogen, getting moles of him, and now based on the way the question reads, I can go moles to another substance. Did that answer your question? Hopefully through the Schoology practice, as you go through it on your own, you'll start to see it a bit clearer. All right, y'all. Remember, the trick here is what's coming first, the Stoic or the gas law? And then the other will fall second. For those of y'all at home, I didn't get your effect either, so I don't know what normal means. The large one or the short one? Okay. Let's see if you agree with my work. I noticed the question's asking for volume, which is a good indicator that stoichiometry will be necessary first. I can also see that the chlorine has these other values that are describing it, but then the sodium chloride is kind of off by itself. So if I can turn the sodium chloride value into something that will help the other values describing the chlorine that it's asking about, then it will help me solve the problem, which is why the stoic will happen first. So I'm going to take the 28 grams, forgetting what it is, of NaCl, and I want to use it, turn it into a helpful unit with the other gas data, which will be moles. Now, the grams of NaCl is not helpful. You always must start a grid with moles of whatever that starting substance is. And then you can go to moles of anything, any other substance. In this case, I'm going to choose chlorine. And I can stop there because moles will be useful for ideal. Drag my diagonals. Moles compared to grams is 1 to periodic table. If you add 1 sodium plus 1 chlorine, you'll get 58.44. Moles to moles is the coefficients of that balanced equation, which for chlorine is 1 and for sodium chloride is 2. And this gives me 0.24 moles. Now we can refocus on the item it's asking about, the chlorine, and use all of that other data that it has to describe its gaseous properties. So let's plug into Pivner. The pressure given is 287 kPa. The volume is what we're looking for. The moles were just calculated. The R value will be pulled from your constant values based on kPa this time. So hopefully you went and found the number 8.31. The temperature was given as 35 degrees Celsius plus 273 will get you to the required Kelvin of 308. .31 is the R value connected. Pull it back again. Do you see it? I get 2.1 liters as a final answer. Hooray for 2 stupid videos.